Louis Schipper is a principal investigator with the New Zealand Greenhouse Gas Research Centre. He's been researching greenhouse gases on Ben and Sarah Troughton's Waikato dairy farm for over 10 years. Louis and his team are looking at the effects of mitigation practices on maintaining soil carbon levels and reducing nitrous oxide emissions in the agricultural sector.
The Greenhouse Gas Centre is trying to find ways to decrease the amount of greenhouse gases that are emitted from New Zealand agricultural systems, and particularly trying to find different mitigation strategies that might work on farm to decrease either the amount of methane that's emitted or nitrous oxide, and also the amount of carbon dioxide that is emitted or perhaps captured by the soil, so that we end up with an overall decrease in the total amount of greenhouse gases from New Zealand agriculture. We're really interested in both carbon dioxide and nitrous oxide, so we're trying to find ways, management practices that will decrease the amount of nitrous oxide emitted, but also might be able to capture some of the carbon dioxide that's in the atmosphere and store it down in the soil as organic matter or soil carbon. Working with whole farm systems is absolutely critical. We need to be able to find mitigation strategies that work within the farmer's philosophy. You know, are they going to be able to manage it within the way that they want to be able to manage the land with the objectives that they will have? So we've got to be working at farm scale and directly with farmers where we can.
Ben and Sarah run now 500 Jersey cows on a 200 hectare farm. When we first started working here in 2011, it was a much higher stocking rate, somewhere around about 3.5 cows per hectare. They've helped us as much as we've helped them. Ben's had a lot of great ideas that have helped improve the way that we do things, give us different ideas, different ways to do things. An example last year was we attempted to get small plantain in the paddock here, and Ben suggested afterwards, let's run some stock in there and try and get good contact between the seeds and the soil, something that we hadn't thought about, the seed rep hadn't suggested to us, so that was a great example of sort of being able to work with him, someone that tends to think a little bit outside the box as well.
And so this is the QCL itself, isn't it?
The QCL itself, the black box.
And so is that just a backup?
That's so we can get the data off here and back.
So what we're looking at here is trying to see whether plantain in the sward can decrease the amount of nitrous oxide that is emitted. Now what is critical here is that we should be thinking about all of the greenhouse gases coupled together. So we want to try and find ways of decreasing nitrous oxide, but ensuring that we don't lose carbon dioxide through that management practice. There have been a number of studies around New Zealand, smaller chamber type studies where they've had different mixes or amounts of plantain in the soil, and they have demonstrated decreases in nitrous oxide emissions. The challenge there with chamber studies is that they're relatively small, maybe the size of about a foot across or something like that. And how do you integrate that up into a paddock? So you can see around you here, we've got entire paddocks, and you've got a whole mixture of urine patches and dung patches that have been deposited over various lengths of time. And the question then is here, can we observe an overall paddock scale effect, decreasing nitrous oxide emissions when we've got plantain in that sward? Those preliminary studies with chambers show good possibilities. Now we want to kind of try and check here whether we can see that same effect but at a larger scale. With time, we'd hope in the next year or two, we'll be able to look at the comparison between the paddock that we have here, which is under plantain, versus the one that's next door, which is under ryegrass clover. And we're hoping that we'll be able to see a difference in the amount of nitrous oxide emitted from those two paddocks. What are the big ones for?
The bigger ones are the soil plots, so where we take ammonium and soil nitrate samples.
Okay.
And then those ones are...
they're for the chambers?
Yeah, they're for the
you can see the little
gas measurements. Yeah,
like
exactly. So that's what's going on. My main focus is on nitrous oxide, which is one of the most 3 important greenhouse gases. And here on the site, we're trying to identify how the emissions look like at different scales, like at the paddock scale and at the chamber scale as well. The QCL is measuring at the paddock scale, but you need to know that the QCL is an analytic device which is capable to detect greenhouse gases in the atmosphere and is capable to measure those 10 times per second. and at higher frequencies and across these scales combined with other devices we have. We implemented the whole system in November 2016, so we had different stages we were looking at really. And at the moment it's Plantain. Previously we also had normal ryegrass and clover pasture. These are static chambers, and this is a well-acknowledged technique to measure treatment effects on nitrous oxide emissions from pasture or plantain in this case. So we applied this treatment like a urine treatment to the chamber and now extract a sample from the headspace. You have different time stages, so after 0 minutes, after, for example, 20 minutes, 40 minutes, and then finally 60 minutes, because the aim is to actually identify an increase in nitrous oxide in the headspace and to later on measure that and then calculate a flux. We got some preliminary results, which are really exciting. Of course, we need to look into those a bit further, but what we can report is that during the renewal phase of Plantain, so breaking down the old sward and establishing Plantain, we actually received high emission pulses of nitrous oxide. We need to figure out what the real factors were triggering those and for how long they lasted. But at the moment we can say that within the first 35 days, those were quite high. Also important is to reseed quite quickly so that the plant cover is established within, let's say, 4 days in our case. And finally, this is what we probably have to do in future still, is to find out whether the effect is masked by other factors, because the grazing is at some stage continuing, also probably fertilization and other farm management practices. So we need to find out whether the establishment stage of Plantain has any offsets to the benefits we associate with that plant later on.
Thanks, New Zealand On Air.